Evaluating and writing expressions. At the end of this lesson, you need to be able to translate verbal phrases into algebraic expressions and be able to answer the question, how do I evaluate an expression when given the value of a variable? It's important to note that we evaluate expressions and we solve equations. Often students will say, oh, that means solve it, but technically we're evaluating. And when we do this process, it is necessary to always follow the order of operations. PEMDAS is one acronym students use to remember this order. Some other students say, please excuse my dear Aunt Sally. One common misconception with the order of operations is that students think that multiplication must be done before division. That is false. Technically, they have the same strength, so you do what comes first in the expression from left to right. The same is true with addition and subtraction. Let's illustrate this with the examples on your note page. In the first example, if we're following PEMDAS, we need to go inside the parentheses and look at what is strongest there, and it would be the 4 to the second power because that's an exponent. So I'm going to recopy the first part of the expression, and 4 to the second power would be 16. Next, I still have parentheses, so I'm working inside here. I have addition, division, and multiplication. Multiplication and division are stronger according to PEMDAS, but we do what comes first from left to right. So this would be 6 plus, I have to do 12 divided by 3, is 4 times 16. Next, I still have grouping symbols. Multiplication is stronger than addition, so 4 times 16 would be 64. Now I have 2 times 6 plus 64 would be 70 to get a final answer of 140. In example 2, we have an algebraic expression. 4a plus 3b means 4 times a plus 3 times b. We now know that 4 and 3 are both coefficients. So we are going to use the substitution property, which states you can take out the a and in place of it put what is equivalent to a and do the same for b. So since a is 6, I'm putting that in the first set of parentheses and negative 8 in the second. Now it's necessary to follow PEMDAS. So I will do the multiplication before the addition. 4 times 6 is 24, and 3 times negative 8 is negative 24. So 24 plus negative 24 gives a result of 0. This is evaluated. In the third example, we have a numerator and denominator. So I'm going to first start by using the substitution property and plug in negative 5 in place of k. Notice that I put negative 5 in parentheses because this is saying whatever k is being squared. And that indicates that I'm doing negative 5 times negative 5 up in the numerator. Alright, so what you do with a fraction is evaluate the numerator and denominator separately, and then once you have it down to one number on top and one number on the bottom, you will do your division. So negative 5 squared would be 25 minus 1 over negative 5 plus 3 would be negative 2. This would result in 24 over negative 2. That means divide to get a final answer of negative 12. When it comes to writing algebraic expressions, it's important to know the list of vocabulary words on your note page. I would keep this in a safe spot to refer to it frequently until you understand all these words and what they mean. Okay, so in this first algebraic expression under example B, I'm going to start by indicating the keywords I see, such as twice. And if you look at the chart, that specifically means 2 times something. Sum. Sum is an addition word. N is a variable. So I've got 2 sets of words here, and this means twice the sum. So I've got to figure out what that sum is first. So it's telling me to add n and 16. So I'm going to write n plus 16. Now it's twice that entire sum. If I just put a 2 right here, that means just 2 times n. I want it to be 2 times what I get after I add, so I put parentheses around that n plus 16 to recognize that I have to add that first. In the second one, let's identify our key phrases. I see quotient of. Quotient means divide. And then I see increased by, which is an addition phrase. Okay, so the quotient of a number, x and 4. So quotient means divide. I would have x divided by 4, and then that is being increased by 7. It is not wrong to write it as x divided by 4, but in higher math we use a fraction bar rather than that division symbol. The third one illustrates a common error. 8 less than means subtract. The product of, product is on your chart as a multiplication word, the product of a number a and 9. Now, 8 less than. Whenever I have the word less than, if I just put 8 minus something, that will be incorrect. So I'm going to get rid of that. Instead, what I want to do is handle the product of a number a and 9 first, which would be a times 9, and the best algebraic way to write that would be 9a, where 9 is a coefficient. And then 8 less than that product would be minus 8. So kids will often write this in this form, and what I'm saying is this is incorrect. Now let's look at writing an algebraic expression for more real-world problems. It says, piece of ribbon x feet long is cut from a piece of ribbon 8 feet long. Write an expression for the length in feet of the remaining piece. So here is my original piece of ribbon, which is 8 feet. And I'm cutting something from it, and I don't know what it is, so I'm not going to put it in half because it doesn't say it was cut in half, and that's x feet long. So I need to write an expression that represents this remaining piece. So if I'm cutting away, that means I'm subtracting. So the remaining piece would be 8 minus x feet long. And if that doesn't make sense to you, think about if this were not x, but instead it were something like if this were 2. I think everybody could say, oh, well, that means this here is 6. And you think, well, what did I do in my brain to get that? I did 8 minus 2. So rather than 8 minus 2, the correct answer here is 8 minus x. Second one under example C is very similar. Elizabeth worked out for 45 minutes by running and biking. If she ran for m minutes, how long did she bike? Well, this is very similar to the last one. Her total time was 45 minutes. We would subtract the amount of time she does the first exercise, which is m minutes, to figure out what remains. The remaining time would just be the expression 45 minus m. You can't combine them because they're not like terms. So 45 minus m is the correct expression. You should now be able to evaluate algebraic expressions using the order of operations and use this chart that was given to you to help you translate phrases into algebraic expressions.